Hello everybody, this is Mr. Yen, and this is the video lesson for 7.5c, where we are going to be using congruent triangles to prove different properties about quadrilaterals. So I'm going to switch over to the worksheet for today. Make sure that you have this from Google Classroom, either print it out or open on your computer. You can also show your work on a separate piece of paper and submit that. First, let's review some key vocabulary that we're going to be using for today's lesson. The first is a bisector. We're talking about line bisectors. And it's a line that splits another line into two congruent segments. Or you can think of this as being two equal halves. So it's telling us here that line segment AC and line segment BD, that's these two, are bisectors of each other. So if that's the case, that would mean that each of these lines is splitting the other into two equal halves. So this segment would be congruent to this half, and this half would be congruent to this half. So we can say that the midpoint is E. So I can say AE is congruent to CE. And then also, sorry, it's kind of small, BE. That half is congruent to the DE half of that line segment. Okay, so these two lines are bisectors. Next, the other type of bisector that you can have is an angle bisector, and that's a line that splits an angle measure into two congruent measures. So it splits an angle into two equal halves. So it's telling us here that OP, line segment OP, that's this right here, is splitting angle AOB. So AOB is this angle right here. And it's going to be split into two halves. So that means that this angle, that half, is then going to be congruent to this half right here. So if OP is the bisector, then I can say that angle AOP is going to be congruent to angle BOP. That's the other half of the angle. Next, perpendicular lines. So you know of perpendicular lines as being two lines that form a right angle. What's also true about perpendicular lines is if the two lines are perpendicular, so if line A is perpendicular to line B, then all four of these angles that they create, let's say this is angle 1, this is angle 2, and this is angle 3, and this is angle 4, are going to be congruent to each other. And they're all going to be right angles. So if these are perpendicular, I can conclude that angle 1 would be congruent to angle 2, which would be congruent to angle 3, which would also be congruent to angle 4. All four of those are congruent. Okay. Something else. When two lines intersect, sorry, there's a lot of glare. I'm going to try to reduce that. I can reposition this a little bit. That's better. When two lines intersect, the vertical angles are congruent. The vertical angles are the angles that are kind of on opposite sides that are reflected across. So for example, angle A, its vertical angle is angle B, like that. So from this intersection, those two are going to be congruent. So I can say angle A is congruent to angle B. And then the other set of vertical angles that I have are angle C right here, and its vertical angle is the one across that's reflected. It's angle D. So I can say angle C is congruent to angle D. Those are vertical angles. Last one, and this is a review because we're going to be using it again today. If two triangles are the same, if two triangles are congruent, then all of their matching sides and angles are also going to be the same. And the math phrase that we use to say that is corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. All right, with this vocabulary in mind, let's take a look at the first problem. The given information is that quadrilateral ABCD is a parallelogram. And we know that side AB is congruent to side DC. So let's label that. AB, that's this side, is going to be congruent to CD, that's this side. And AD, this side, is going to be congruent to CB, that's this side, right? Opposite sides are congruent. And then we're being asked to prove that the opposite angles, angle A and angle C, are congruent. So angle A is this here, and angle C is this here. We're trying to prove that that angle is congruent to that angle. I'm going to erase this for now because we haven't proven that they're congruent yet, so I'm not going to mark it so we don't get confused. All right, to guide our thinking, label all the congruent sides, we did that. And now we want to know, how can we use congruent triangles to prove that this angle is congruent to this angle? Okay, notice how this diagonal BD is there to split this into two triangles. So if I can prove that this triangle on the left is congruent to this triangle on the right, that these two triangles are congruent, then I can conclude that angle A has to be congruent to angle C because they're corresponding parts of congruent triangles. So what I can say here is, well, if triangle ABC, that's the one on the left, is congruent to triangle ABC would be CDB. DB. Order matters. Then I can prove that angle A is congruent to angle C. So the reason why I ask you this question in the beginning is because this is what's going to guide your thinking for how you're going to set up the rest of your proof. We know we want to prove that these two triangles are congruent first, then we can conclude that angle A is congruent to angle C. Okay. So since I got it started for you, what I want you to do now is actually to pause this video and see if you can finish the rest of this page on your own. So now you're pausing the video, try to finish the rest of this page, and then when you're done or when you get stuck, then you can resume the video to finish it with me. So you're pausing now. Okay, and now you've tried the rest of problem 1, and you're coming back to check your work, or you got stuck somewhere. Okay, let's list the three congruences from the given statement. And remember, we wanted to prove that triangle ABC is congruent to triangle CDB. Between the two triangles, we know that side AB is congruent to side CD. We know that side AD is congruent to the top side CB. And in this instance, we have a third side that we can use. It's this shared side. That one right there. So I can say that side BD is congruent to itself. And between these two triangles that I'm trying to prove congruence, I've listed a side and a side and another side. So I can conclude that triangle ABC is congruent to triangle CDB because they share three congruent sides. Right? Or side, 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 SSS for short. Now, we ultimately want to prove that angle A is congruent to angle C. Well, we've already proven that the two triangles are congruent, so now we can conclude that all of the remaining parts are congruent. So I have angle A is going to be congruent to this angle here. I have this angle here, which is going to be congruent to this angle here. So this is angle ADB. It's going to be congruent to angle CBD. And last is this third angle up here. That's being congruent to this third angle here. So this is angle ABD is congruent to angle CDB. Okay, so those are all the remaining parts of the triangles that I now know are also congruent. Therefore, concluding statement, what was it that I wanted to prove? I wanted to prove that the opposite angles A and C are congruent. So to put that into my conclusion, therefore, angle A is congruent to angle C. That's what I was trying to prove. And the reason why I know that that's true is because I proved the triangles are congruent, and then therefore the remaining parts are congruent. And the math way of saying that is because the corresponding parts of congruent triangles are congruent. If two triangles are the same, then all of their sides and angles are also the same. Parts. Sorry, I wrote a little quickly there. All right. And that's how you finish number 1. Okay, I will quickly go over some things in problem 2 and problem 3 that are helpful for you. So in problem 2, it's over here. It's telling us that this is a rhombus. And then what it's asking to prove is that diagonals AC and DB bisect each other. So since we're talking about two lines bisecting each other, right? Remember, you can go back to our diagram and our definition for bisectors, and this is going to help you out for number 2. And then number 3, let's see if I have that somewhere. Maybe I don't. Oh, here it is. Number 3 is you have a square and it's asking you to prove that the diagonals AC and DB are perpendicular to each other. So when you're trying to prove that things are perpendicular, remember, go back to what we know about perpendicular lines and the congruent angles that they form. So that'll help you out for number 3. That's all for me. So I will say goodbye and good luck.